Welcome everybody. Thank you for joining me today, and I appreciate you taking some time out of your day to listen to this presentation. Recently we've been hearing a lot in the marketplace about cloud native and DevOps, and certainly it's been taking a lot of interest by some of our customers. But when you look at cloud native and DevOps, it's such a big topic. I think some of our customers are really daunted by what it actually is and what it does. I think what I'd like to discuss today is what actually is cloud native and what is DevOps, and is it something really new? Is it something we're already doing? And more importantly, I want to talk about the business impact you can bring using this thing called cloud native. So I'm going to go through describing what I think you may already be doing, and then how can you use cloud native tools to actually wrap around your existing organization and the things that they're doing around IT development. But more importantly, how can you get impact today? Because some of the things that we're seeing in the marketplace being told to us by customers, cloud native is being billed as something that's 3, 4, 5, 6, 7, 8 years out. And it seems like it's a very daunting investment. As well as talking about how you can look at cloud native tools and the idea of DevOps, I'm also going to go through some financials in terms of ROI and TCO. I think it's very important, anybody who's starting out in this vein to go and use cloud native tools, they understand what's the cost associated to it. I think the biggest thing is cloud native and DevOps seems to be associated just with the idea of going towards and building microservices. It's a great goal, but it is super expensive. So in this discussion today, I'm going to talk to you about some examples of costings and how you should think about how to fund a project which includes cloud native and DevOps. So before we start, the first thing I want to do is really ask you to take a look at this safe harbor statement. So what is cloud native? Is it a revolution? Is it a revelation? Is it an evolution? Well, it's interesting. I think it's an evolution. In fact, I pretty much know it's an evolution. So what do I mean? So when I go to somebody and talk about cloud native tools, people see cloud native as a whole array of applications that they can use for various functions in their IT, particularly around their applications. But the thing is, it's linked to what we call DevOps, i.e. a process. And again, when I talk to customers, the buzzword today is DevOps, and customers are saying, I've got to look at that. But actually, when you go back and look at what's going on in your own organization, you're actually doing DevOps already. And what do I mean? Well, if I take a little example, if I was a developer 15, 20 years ago, and I developed some code, and I decided to deploy that, and I go to my data center operations person and say, please can you put this on some server or hardware or a VM, have it provisioned up, get the application installed. And when I come to test my application, I find my application is not working. So I spend the next 3 months hacking my code, decoding it, debugging it, to find out what's wrong with my code, it's not working. After 3 months of effort, I realize my code is okay, and actually there's a configuration error in the hardware on which it was deployed. As a developer, I've just wasted 3 months of my time trying to understand where the problem was. So I go to my data center operations person and say, look, the next time I give you some code to deploy, I need you to run this script to deploy it. Once you run the script, I want you to run a test script. And once you test it, then let me know the output of the results. I'll examine that, and then I'll give you the code to deploy. The fact that I've had a bad experience with my coding and discovered it was a hardware configuration issue forced me or put me under duress to create a process to stop it happening again, because I couldn't afford to lose time. So I ended up as a developer going to my data center operations person to actually introduce a process to stop me going through the same pains again. This process I've just described is DevOps. But the difference here between what I've just described there and what's being touted today around DevOps is that this was not done proactively. It was done under a stressful situation to stop things going wrong again in the future. But the point is, it is a DevOps process. And most organizations are doing this today. It's just that it's not labeled DevOps. I've been speaking to customers, and when I talk about DevOps, they say, yeah, we've got to look at this. But when I say, well, actually, you may already be doing this, and they give that little example, they go, yeah, we are. So if I'm already doing DevOps, and it's not proactive and it's not structured, what's this cloud native thing? Well, cloud native is a set of tools which actually allows you to automate your DevOps processes. So DevOps is actually an evolution from something we're doing today. And cloud native is part of that evolution to actually automate those processes so we're proactive in doing so. So it is actually an evolution. It's not something new. What we've done with cloud native and with DevOps is put a category around this process and the tools that will help automate these processes. So we have a go-to place to go and find them without looking all over the place. So it's not a revolution, it's not a revelation, it is an evolution. So what's the goal of this presentation? Well, I do want to bring it back to money as well. Any project does have to have a financial outcome. And it doesn't matter whether it's internal use case in your organization or whether you're developing an application, we look at financial outcomes. So there are three things I want to talk about in my presentation alongside the two things that you can really do to create impact today from a technical perspective. So I want to discuss what's the long-term cost and investment you have to make when embarking on a project like this using cloud-native tools and standardizing DevOps processes. I'll show to you in an example of an organization with 1,000 servers how to save $20 million of hard cash over 7 years. Now, why did I pick a 7-year period? I picked a 7-year period because what most people don't understand or realize is that during a dev test phase, you end up burning cash before you go live into production. In my journey around the world speaking to customers and application developers, I've been learning that a lot of these customers have been starting such projects and going to places like Amazon, Google, Azure, finding the cloud native tools that they want to try and work with and start subscribing. Very, very quickly, they don't realize they're into a 2 million, 3 million, 4 million cash burn and they haven't got a project ready. They start off small and it ends up growing very, very quickly. So I call this the 2-year dev test period, and you have to include this in your financial analysis. And then once you get past that, it's you've got the 5-year production analysis as well. So I'm saying, I think on a 1,000 server estate compared with other technologies in the marketplace, I can save you $20 million of hard cash. And I don't mean soft dollars, i.e., other metrics in the organization which equate to money, but actual money you have to part with. And we're going to measure it over 7 years, like I said, to make it a fair test. The second thing I'm going to talk to you about is by using cloud native tools and DevOps strategies from Oracle open source Linux software, I want to show you how you can increase your ROI by 44% from 35% to 44%, getting an ROI of 79% compared to other solutions in the marketplace. Now this is important because this links back to how much cash you put into a project and when do you get that cash back. And then the last thing I want to talk about in terms of monetary metrics is achieving break-even. When you invest in tools like this and a DevOps process, we're getting feedback from customers. These whole projects are taking 7, 8, 9 years. But for the business who's going to invest in this, how much are they going to invest? And when do they get to break even and get their money back? And I'm going to try and show you with this example of 1,000 servers, you get to break even with Oracle open source Linux software in 25% less time than other vendors in the marketplace. So when you're selecting a vendor to embark on these projects, it's not only important to look at the technology and the tools, it's also important in looking at what's the investment going to be and when you're going to get your money back. If you can't tell your CFO how much you need and for how long and when they're going to get the money back and when's profitability going to come back, then you're really opening up a blank checkbook. Not so long ago, many organizations started projects using OpenStack. As everybody knows, OpenStack is a common framework for managing multiple hypervisor virtual environments. I have seen and spoken to many customers who started without a financial plan in front of them and end up putting $30–40 million into a project, not knowing when it was going to end, and ending up cancelling the project and writing off the debt. I would not want this to happen to you. And one of the things that we do at Oracle is to help you understand what's that long-term investment and when you're going to get your money back. This will help you go to your CFO and help justify the investment you need. So from a financial perspective, I've just explained what are the financial goals we're going to look at. But technically, what are we going to do? So what's the goal and where are we going to go to try and make improvements and impact the organization's IT architecture from dev to infrastructure? So there are 4 different areas. The first one to think about is your actual processes. At the beginning of this presentation, I already talked about these processes existing. The question is, do you want to create some impact here? Then there's actually your application architecture itself. When you move to DevOps and cloud native, most customers I speak to are assuming it means you're moving your whole infrastructure and your applications to a microservices environment. It's all well and good trying to go for a microservices environment, but is it necessary? Well, I would recommend it's a path to go to, and it's got to be good for the organization. It creates agility, it creates speed and time to market, keeps you relevant. However, the time to get to microservices could be long, given that you may have a monolithic application or an end-to-end architecture application. So we want to look at, through this presentation, what can you do today without having it to be a microservices result. Then there's deployment and packaging. Can you use cloud native and DevOps? If you've got a physical deployment, physical server deployment, can you use it on virtual servers? Can you use it in containers? Or is containers the way you need to go? Again, a lot of organizations I speak to start talking about, well, we've got to containerize our applications to leverage these benefits. Not necessarily. You can leverage some of the benefits of cloud native and DevOps without having to even move your application workloads off of physical servers. So we'll discuss that as part of the opportunity. And then the infrastructure itself, is it cloud, is it hosted, is it in a data center? Does it have to go to a cloud? Well, no, it doesn't. So the point here is that whether it's 1, 2, 3, or 4, you don't have to follow a rigid process to implement cloud native and DevOps. You can take 1 and 2, or 3 and 4, or 1 or all of these, or all of the above, or one of the above, or a couple of the above, and address some of the tools and start the path today to improve some of the processes. The whole goal is picking a part of the organization, whether it's your process, your application architecture, your deployment and packaging or infrastructure, picking one or all of these and saying, what can I impact today, and start the process of automation. And what is the goal of automation? It's to create a standardized way of deployment and examination and actually going forth and implementing new projects in a consistent fashion with agility and with speed, using automation tools to eliminate human error. It's all about autonomy. So when you start looking at implementing some of these tools, and at the beginning of the talk, I said it's all about having a structured approach to DevOps and using cloud native tools versus doing it under stress and duress. So the first thing we've got to look at is if you're going to start to be structured about implementing some of these DevOps processes, then number one, which is really, really crucial, is that the development people of the applications and the people who are managing the data center operations, looking after the infrastructure, need to agree proactively that they do want to work together and design a process that allows them to deploy, test, and come back and redo and test and then go into production with some of the applications. Having a proactive process is what's going to help eliminate a lot of mistakes. So the first thing is the two groups, the developers and the data center operators, need to agree and to collaborate, to communicate, and what that process looks like. So once they've got an agreement, on collaboration, and this is a humanistic thing, it's not an automation tool, it's just a bunch of people agreeing. The next thing is to design the process. So if we're going to go from a process which was designed under duress and stress, as per the example at the beginning of this talk, and be proactive, then we've got to create a structure and a process with a structure that both organizations in the company can follow. So you have to design a process which says if you're a developer and you've done some coding and you want to then move it into the data center and deploy it, what do you need to do as a developer first to click the checkboxes? And then when you click those checkboxes, what do you then need to hand over to a data center operations person? What do they need to do? When it fails or it needs readdressing or something needs addressing with the code, what do the data center operations people need to do to pass it back? It's designing that process and putting some structure around it. So designing the process comes after you decided you can collaborate, the developers and the data center operators agreeing to collaborate. They then sit down and design a process. Designing a process is again a human effort. It is a humanistic exercise where people come together and decide what those processes are, design it on paper. Once those processes are designed, then you want to look at how do you automate those processes. So you've got a DevOps process built, you've got a DevOps culture created. Now you want to look at automating those processes. And in actually the third part of this conversation, what you're looking for is the tools to automate it. Those tools are what are called cloud native. And when you look in the cloud native stack of tools available, what you then need to do is to say which tools will automate the processes that we have designed. So what is key to all this is having a culture to modernize your applications. And it starts with people. Once you've got your people collaborating, you have to then design the processes. That is another manual human exercise. Once you've got your processes designed, then you go to your cloud native tools and then you actually implement the right tools for the processes you designed. So you end up with the culture which is really based on people, the people rating the process, and then the process dictating which tools you need, i.e. the products to do that. So just take a moment and what is that process? There's a general structure out there in this infinity symbol. You'll see it's a build, code, plan, monitor, operate, deploy, release, test. All these are the high-level architecture of the process that we're going to look to design in a DevOps culture. But each of these sections is a process in itself that's designed by you in your organization, and it will be different for your application, different for each department, different for each company. Once you've designed the processes in these categories, is then you look at your cloud native tools to see which tools will actually deliver on the processes or automate the processes you've designed in each one of these categories. So you can see this infinity curve, it's all over the internet, but this is the general structure of how you go and look at which categories you need to address in building a DevOps process. And I did mention earlier, this is not something new. This is something that you're already doing. And at the example at the beginning of the talk, I did describe an application developer who deployed some code in the data center, find out it didn't work, spent 3 months trying to debug it or hack the code to find out what's wrong, and then discovered there was actually a data center configuration issue. All we're doing is layering automation and a structured agree process on top of that process that already exists in your data center. Nearly every organization that has application development going on in their organization has a DevOps process. It just may not be labeled as that. So what is cloud native? I've already talked about it. It's actually tools. And if you see this slide that just pops up on the right, or just below, the tools landscape is vast. And this is growing every month. This is probably out of date by the time you hear this presentation. But by now, it's probably another 10x number of tools. And you'll see, there's different categories. There's application development, there's orchestration, runtime, provisioning, infrastructure. Tools to automate every part of your IT architecture. These are the tools that will enable your processes designed to be automated. Automation just talks about that. It also provides consistency. Once you create automation, one of the things that you use in your automation is a standard design of implementation. It could be playbooks, it could be gold images, whatever it may be. It drives consistency. Because you have a proactive, structured process, and you've got a process designed which can be automated with identified tools, it means everybody knows what they're doing, and it speeds up your time to market with your applications. Having the process also allows you to be agile. What does that mean? Well, if your application needs to be modified and redeployed in super uber quick time, then having these processes and tools ready to go with automation allows you to be agile in delivering new features and functions to your customers. So who is it for? We've already established that. It's for developers and data center operators. But what's important is, why do we need to do it? It's to stay relevant. If you've got monolithic end-to-end architectured applications today, and you've got server-based infrastructure, etc., 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 you're going to be facing smaller organizations coming to market who are more nimble, who start off building their applications on a cloud-native platform. If your organization's been running on these applications for 15, 20 years, and they are monolithic, or they are end-to-end, then it's not so easy and quick or nimble to actually update and meet your customer's needs. And your customer could be an end customer buying your application, or it could be your internal organization. So staying relevant with the market is why you need to speed up and create some structure around these processes. Staying competitive, again, meeting up against newcomers to the marketplace who have agile development processes, agile architectures, who can provide speeds and feeds quickly on a daily basis. If you've got monolithic end-to-end architectured applications, how do you do that? So moving towards this type of architecture under cloud native and DevOps starts taking you to that place. And survival. Sometimes it can be just a matter of, biding your time as you put something else in place to replace some of the old applications. Some of your applications which are monolithic may not be able to move forward. I would doubt you couldn't do nothing with them, but could you move a monolithic application into a microservices architecture without some major recoding? Probably not. But can you make it more mobile, more automated, more consistent? Probably yes. So you could probably get some of the way with some of the monolithic end-to-end architected applications, but maybe not all the way to microservices. So sometimes it's about biding your time, staying a little bit more competitive in the marketplace while you build a new application. So one of the things I really want to focus on going forward is, what can you do today without it being a huge project? Well, it's always going to be a huge project, but without waiting for the huge project to finish, i.e. getting to microservices. I want to particularly address those customers of ours who are running Oracle workloads, maybe Oracle database, middleware, and really look at the two things that you can do and what's the impact you can make. And these two things can really help you whether you re-architect your application or not. So the first thing I want to talk about is containers. Containers is a really good technology, and the idea of containers is to abstract yourself from the infrastructure. Take yourself away from the infrastructure and make yourself less reliant on the infrastructure. Operate your workloads not bound by your infrastructure. And everybody today know what container is. But how has Oracle made it easy for you as an Oracle workload user to implement containers? Well, first of all, what you can see on the screen here is as a screen grab of what is our container registry. If you go to the Oracle Container Registry, what you can do is download pre-built containers for Oracle Database, middleware, MySQL, and many other Oracle applications. These containers are already pre-configured, so you can download them free of charge and actually implement them very, very quickly. If you downloaded the Oracle Database container, what do you need to do next? It's probably just import your schemas. We're trying to take the pain out of implementing containers. Now, by implementing containers, you become mobile across any infrastructure. What does that mean? Well, if you're using in your data center today physical servers and you move your Oracle database to a container strategy, you can then move those containers to a virtual machine. You could go a step further. You can move that container very easily just by lifting the container and moving it to a cloud. So it allows you to abstract yourself from the infrastructure. So let's look at that and what that looks like. So here's an example, and on the right hand side you'll see I've got the container registry depicted, and there's some pre-built containers you can download from Oracle. On the left hand side you'll see a physical server, and the first step to doing this is actually installing a couple of hosts. You need a host for your containers on which your containers are going to sit. This host gives you access to system resources. Now this host can be sat on a physical machine, it could be sat on a VM, it could be sat in the cloud, it doesn't matter. It's Oracle Linux UEK. So Oracle Linux UEK is the recommended host for Oracle workload containers. You then go to your Oracle Container Registry and you download a pre-built container for Oracle Database. Pretty simple, yeah? There's a little bit of work to do, but we're trying to take the pain out of it for you. The next thing you want to do is actually build some sort of mobility or orchestration, because if you download and build a container on Oracle Database, it's on your physical machine, and then you think you want to move it to your other data center, which may be in Amazon, it may be a virtual environment on VMware, then you want to use some sort of orchestration, and Kubernetes is the way to go. So Kubernetes is something we support, and again, we have pre-built Kubernetes for you to download and implement to make it easier. So now you've got Kubernetes installed, you can actually then import your Oracle database, and once your Oracle database is imported into the container, you can then be mobile. You can move from any infrastructure to any infrastructure. Now, all this seems a little bit simple, but to help you, what we are including, and in this example that I'm showing to you, which is a 1,000 server data center, which is not particularly large, we include 2 weeks of consultancy, or what we call start and go. So to take the pain out of implementing this even further, as well as actually having the containers pre-built for your Kubernetes, the containers pre-built for your database, we also send in a consultant for 2 weeks to set up this environment for you. One of the things you can't underestimate is education. If you get all this software, the first thing your engineers have got to do is read up and learn how to do it. But we want to take that pain out of it for you, take the sting out of that, is get it up and running and teach your engineers on the job how to do the basic things. They can come back and read the manual later on. So we include that to make it easier. We think this is important. It's not hard technology, but time is what we're saving you here. It's not complexity, it's time. So I talked a little bit more about once you move to a container technology, well, what does that mean to you? So moving to a container technology, it could be a monolithic application, it could be an ented application, but once you're in a container architecture, all your applications sit above the operating system, and in this case, Oracle UEK is the host. It now doesn't matter whether your application runs in third-party public clouds, virtual machines, i.e. private clouds, or physical servers in a data center. Well, what do I mean? Well, because your application is abstracted above the infrastructure, you're no longer bound to the infrastructure. So some of you may see solutions out there called converged infrastructure solutions. That's an attempt by hardware providers to tie the applications on top through these technologies to the hardware and cause lock-in into the actual the vertical solution, which may be branded, maybe Cisco, maybe HP, maybe Dell, any one of the above. By using container technologies and Kubernetes from Oracle Linux, we abstract you from the hardware and take that reliance away. We use pure open source tools. We don't use any hybrid tools. We don't make any adjustments to the tools that we download and offer, and we don't make them proprietary in any way. We use it pure open source as it comes from the community and support that. What that means is that we can abstract you from any infrastructure, like I just said, and all of a sudden, the operating system is all you need. The operating system is what becomes your infrastructure, not the VM underneath, not the public cloud like Amazon, Google, etc., not your physical server in the data center. Also, when you're free from your infrastructure, the infrastructure becomes irrelevant. This is one of the first big steps you can do to actually drive costs down in your data centers, to move your applications to containers, particularly if you're using Oracle workloads. You can download the containers as I told you. But by moving to container technology, you can abstract the applications from the infrastructure, and you can separate and bid your infrastructure costs down without the association or reliance of the two being tied together. So the idea that these converged infrastructure solutions that are out in the marketplace, where they provide you the storage, the server, and the software and everything put together, is actually a way of locking you into their technologies. What you should be looking at is how to abstract yourself from that infrastructure and stay independent. Make your solution horizontal, not vertically tied. So we just talked about containers, and you still may not be ready for containers. So let's take it down a notch even more and make it even simpler for you to actually take advantage of cloud native tools. So one of the things that we look at is as part of the Oracle open source software stack, we also provide a tool called Ansible. There's another tool called Terraforms. So we take the standard open source Ansible, no frills attached, there's no proprietary tools, it is the pure Ansible tool. And for those of you who don't know, and I think most people know, Ansible is a deployment tool. So if you've got a monolithic application, you've got an end-to-end architecture, you've got physical machines, you've got virtual machines, you've got cloud instances, you don't have to change anything to take advantage of Ansible. So to help you with this, Oracle has what we call pre-built Ansible sample playbooks. So the way Ansible works is it has an Ansible controller or a manager, whatever you like to call it. And with the Ansible controller, it can take a playbook in which you configure how you want your server to stand up. So in this particular instance, I'm showing I've got UEK playbook. We give you a sample playbook. We can't give you an image because every environment is different, but with the sample playbook, it will show you how to configure a specific playbook for your infrastructure. So in this example, we get UEK as a sample playbook because we want UEK for containers. And we want to make sure our 1,000 servers are all deployed exactly the same. So with this playbook, we got the configuration, and using Ansible, we can actually deploy the playbook into either a server, a cloud instance, or a VM. And that playbook will then give the instructions on how they want that server configuring. And in this case, we get UEK configured. But the great thing about these playbooks, once you've got them set up, is you can send these playbooks to all the servers, hundreds, thousands, and within minutes, you could be deploying the same configuration for, in this case, Oracle Linux UEK, ready to actually receive container hosts. So without actually having to even do anything to infrastructure, you can implement Ansible and actually automate the actual deployment of just basic operating systems. You can go a step further because we provide Ansible sample playbooks for a lot of the Oracle workloads like database. So you may want to go a step further and say, right, not only will I deploy in a standard format the operating systems and standardize that and remove human intervention to deploy them, I can then extend that to the Oracle database. So we give you these sample playbooks to be able to automate what you're already doing manually. So this eliminates the need for a human being to go and configure every single server in your data center manually. By automating it using Ansible and Ansible playbooks, we provide you the sample playbooks. You then go to the database layer and we do the same for database. It takes human intervention out of it. It drives autonomy. It's the key theme of Oracle these days is how do you go autonomous? How do you drive autonomy into your architecture? These are some of the ways we're helping our customers do this. But again, we don't want you to do it on your own. We've given you the sample playbooks, but what we're looking at is, how can we help you? Again, don't underestimate the cost of education. Do you want your engineers stopping what they're doing and learning, or let us come in? As part of this 1,000 server example, we would come in and give you 2 weeks of consultancy, get the Ansible architecture up and get the playbook set up and be able to show your engineers how to do this quickly. They can go and read the manual later on. So again, two things that you can do quickly and easily is containerize your applications, particularly Oracle workloads, and make the infrastructure irrelevant and and abstract yourself away from the infrastructure. And number two is implement Ansible to standardize deployments. And these two things you can do today without having to go and build a microservices application and spend the next 10 years doing it. By implementing this today, you get immediate impact. Now, how do you pay for all this? And this is really important. So I'm giving you two things you can do today, but it still costs money. So I'm trying to show you some examples here. Now, it could be RHEL giving you these tools. It could be Amazon. It could be Google. It could be Azure. Any one of these places is where you go to buy these subscriptions to use these tools. So it's very easy for me to find pricing on the internet for Red Hat. So I'm using Red Hat as an example. So I want to have a disclaimer here. I've done my best to understand Red Hat pricing. It's not easy. I think I've got it close or right. If I haven't, forgive me, but I don't think it's far off. I've tried to test this with a couple of customers, and I've heard from customers of these figures being quite close or actually a bit conservative. But the idea of these figures is to give you an idea. I'm not here to compete against Red Hat pricing. I just want to show the ROI. So in this example, I'm taking 1,000 servers because this is the example I've always been talking about. And with management and high availability tools, I think the list price, for instance, is $6,469 at Red Hat. I've applied 50% discount. I'm assuming most organizations will get a discount, trying to make this real. And if I look at that, just on this piece here with management and HA, it's $3.2 million a year in subscriptions. It could be the same in Amazon, it could be the same in Google, similar. And by the way, what I haven't included here is the cost of the actual infrastructure. This is just the software piece. So on top of this would be your cloud subscriptions or the cost of your hardware or the VMs. The next thing is Ansible. So with Red Hat, again, I've tried to look on the internet. These are publicly available, these prices. I think they charge $175 per year for each active node which is managed. So there's 1,000 nodes that we want to deploy to. And again, I've applied 50% discount, and there's like $85,500 per year in subscription. Bearing in mind, you've got to pay this year in, year out. And right at the beginning of this talk, I did say we're going to look at this over 7 years. And then the OpenShift container platform. Red Hat have got a slightly more complex pricing than I was expecting. So here we've got 3,000, just under 4,000 per 2 cores per server, per 2-core server. So 2 cores at 2 times 2 core CPUs. And I'm not going to assume that all 1,000 machines are going to be Linux hosts. So I'll put 200 nodes with 50% discount for 200 nodes. We're looking at just under $1 million per year subscription. So when you put all that together with 50% discount, a 1-year subscription cost with Red Hat is $4.3 million. So if this is wrong, there's a disclaimer there, but I think it'll show you where we're trying to get to here. This is not wrong though, is the Oracle Linux price. So 1,000 instances of Oracle Linux will cost you just under $1.4 million. 1,000 Ansible managed nodes, 0. We include that in the price. 200 nodes of containers and Kubernetes, 0. This is your OpenShift, the equivalent to OpenShift container platform. 1,000 nodes of clustering HA, all included. 1,000 management, all included. The total cost is 1.399 million versus 4.3. We include this all in our price. No options. It's straightforward, really easy. So just also you can see straight away the cost savings that you're looking to make. Now, let's start looking at this over the 7-year period. If you look at Red Hat, we said before, 1 year was $4.3 million. So we've got to take into account our dev test year. Now let's just take a moment to talk about that. Even if you did this in Amazon or Google or Azure, what we've been hearing from customers, and I did say this at the beginning, is customers have ended up paying subscriptions in the millions and not knowing when the whole application development will finish and go into production. And I've heard instances where 3 years and 4 years have gone by and they're still not in production. So I'm taking 2 years because 3 and 4 years examples were rare. Most people are spending up to 2 years in dev test. And with the Red Hat subscription, because you would have bought it, it's $8.6 million. Now, some of you may not buy the whole 4.3 in one go. You buy it small, but what I've been hearing, it quickly ramps up and it would get past the 4.3 million. But this is just a linear example. So you're looking at 8.6 million in dev test and then 5 years of production. You continue on as long as everything's not grown, it's still the same. It's 21 million, 21.5 million in production. So the total project cost over 7 years is 30.129 million. What's interesting is the customers I speak to don't realize they're going to be into this project for this amount of money. They start it because as a developer or the architects, they go to the CFO and say, I need $1,000 a month to start this project. And they have no idea this is where it's going to end up. So it starts on $1,000, $2,000 for a single instance in the cloud or Red Hat or wherever it may be. And the next minute, you're racking up the subscription charges. So what we try to do is try and forecast that for you. And as we go through this ROI study in the next couple of slides, you'll see how we'll help you have a handle on your finances through these projects. So how does Oracle Linux look? You probably already guessed. So our yearly cost is the 1.399 million. 2 years of dev test, it's just under 2.8 million versus 8.6. That's a huge saving. So right out of the block, you're burning less cash in your dev test period. And Oracle Linux doesn't change how much time you're going to have to spend on your project. It changes how much money you're going to spend on your project. 5 years of production and in going live, and no fixed, inflationary rate adjustments, just a fixed linear cost. We end up with $7 million in production. So total, we end up spending $9.7 million, $9.8 million, 68% lower than Red Hat. And I would suggest it's probably an order of magnitude similar for Google, Azure, and Amazon. So when you start thinking about this and you start going to your CFO and you say, well, actually, I've got to run this project for 2 years of dev test, you can turn around and say, 2 years of dev test is going to cost me $2.8 million with Oracle and $8.6 million with Red Hat or Amazon or Google. Now, what's important is that from an Oracle's perspective, what we provide you as tools is the standard open source tools. We don't create any wrappers which make it proprietary and management tools that make it proprietary. Why is that important? If at any part of this financial modeling in terms of year 1, year 2, year 3, year 4, year 5, year 6, you decide you run out of cash, your project doesn't need to stop. We don't switch you off because it is open source, and that is important. If in year 2 you run out of cash for dev test and you have to switch off the payments to Oracle, you can switch off and continue your project relying on the community. With Red Hat you can't, with Amazon you can't, with Google you can't. At any point during this 7-year project, once you start, you've got to finish it, otherwise you're going to have to write off the debt. With Red Hat or with Google or with Amazon, if you decide in year 2 to stop the project, they're going to shut you down. You can't go to the community and continue because their tools are not straight out of the community. They've got their proprietary wraparound. They've created lock-in. So you've either got to continue and burn on cash or you've got to write the debt off. Oracle is fiduciary responsible and thinks about our customer situation. By using standard open source tools, you can continue your project. And then when you go back into production and when you need support again, you can switch it back on knowing our tools have not changed. It follows the open source tools. That's a big safety net. And particularly in economic climates, from one year to the next, you don't know when things are going to change. So what does all this cost mean? Simple slide here. You can see this, that the red line is Red Hat and Oracle Linux, just representing those costs. It's a lot higher. However, all projects have to be profitable. One of the things I've learned in managing P&Ls is that an ROI on cash invested, at 30% is what I think I've learned is being the gold standard. So I'm going to up it a little bit, and I'm going to set the ROI at 35% for this model. And we also got to assume there's some dollars that we get back in a project. So if you are a logistics company, you've got logistics, trucks, airplanes, maybe DHL, and you're building systems for the logistics organization, how does your development impact the revenue and logistics? So, in this case, I've picked a number. Assuming a gross return of revenue, over 7 years, collectively reaching 46.3 million, whether it's your systems creating a $46.3 million impact in logistics sales, or whether you're building an application that you want to sell, ERP system you want to sell, and you want to generate $46.3 million worth of sales of that application over 7 years. The point being is what I want to anchor ourselves on a monetary return, a gross monetary return to the business of 46.3 million for this example. I'm setting the 35% gold standard here, and with that you can see here, if Red Hat costs $30.1 million over 7 years, the ROI is 35%. That's what I set at, and that's based on a $46.3 million linear return on gross revenue. If you take that $46.3 million, assuming that Red Hat costs $30 million and the ROI is 35%, using Oracle Linux not only safeguards you against funding running out and you being able to carry on in the case of, you not being able to continue paying Oracle using standard open source tools, your ROI is 79%. Assuming that you achieve 46 million over 7 years, you could achieve a 79% ROI. Assuming you achieve 46 million in gross revenue over 7 years, you achieve an ROI of 35%. But most organizations, revenue don't go up and down, up in a linear fashion. They up and down, up and down. And it's quite possible you don't get $46 million of return. You might get half that. If that $46 million became $25 million or $20 million, then the ROI on Red Hat is going to drop to 12 to 15%. All of a sudden you're below the gold standard for your organization. This could be important because if you're a listed company, you might have set those goals or stated those goals to the markets. With Oracle Linux, if you set a standard at 30% and you halved your revenue and your revenue expectation wasn't there, you still get an ROI of 30% because you've gone from 79, halving it way over 30%. So you get a buffer on those metrics. Could be important, could not be important, but it's interesting just to understand where we are with that. So assuming we've got the gross return, the $46 million, how do you fund it, and what's the cash you need? Again, cash burn is very, very important, and picking the right vendor from the start is important because as you start, you're in it for the long haul. In the previous slide I explained, what makes Oracle Linux a good choice is that we use pure open source tools. We don't wrap around proprietary tools, we don't wrap around proprietary code. If at any point of the cycle over 7 years you say you cannot fund Oracle Linux anymore, you can switch it off knowing that your tools are open community tools and you could continue to develop if that's the way you had to go. You're not at risk of losing all the money. If you had Red Hat, if you had Amazon, if you had Google, if you had Azure, they all have proprietary tools to lock you into their platforms. They don't use pure open source. And if at any point you actually had to stop because you run out of cash, your project stops because these guys, they switch you off. Oracle cannot switch you off because what we provide you belongs to the community. The community would support you. And then when you go back into production, you can switch on support again. With the others, will you ever get to production? If they switch you off, how are you going to make it? So how much cash is going to be needed? Let's have a look at that for a moment. So this is a cash burn curve. So my example is over 84 months, which is 7 years. But this sample here is a 38-month sample because that's all I need to show. So you can see from Red Hat, from the day we start paying for subscriptions, we go. It gets to about $8.9 million of cash burn. And I think roughly in about month 24, when if you do meet your development goals and you go live at the end of 2 years and go into production, that's when revenue starts coming. Again, assuming a linear revenue path, you start eating into the cash that you put into the actual project. Now here's the interesting thing. At month 24, which is 2 years, you do go live, you've burnt $8.9 million of subscriptions. With Oracle Linux, you've burnt $2.7 million. It's like 60% less or thereabouts. So all of a sudden you can see you need a lot less cash. Not forgetting our tools are standard open source. Here you've cash burn with proprietary tools. Open source does not mean proprietary cannot be made. That's the thing you must consider. Now, coming back to the curve. So we start coming up the curve, and what I want to show you, in about month 30 here, all of a sudden you're cash positive with Oracle Linux. You've got your money back. If you're still assuming a linear growth path to your gross revenue, we're into just under $300,000 of cash positive. We've got our cash back in month 30. At the same point, with Red Hat, you're still $5.9 million in the red. You still not got your money back. It means you're still not going to get your money back until you get to, in this case, I think month 37. So this is an important curve to look at, because if you can forecast, like you can here with Linux, a low cash burn, and you can forecast getting your money back quicker than Red Hat over a time, then surely the combination of having just standard open source tools protecting you from having to stop the funding, and actually the low price, why would you go to any other vendor? Doesn't make sense. So this is good for two things. One is shows you when you're going to get your money back. But if you as a developer want to submit funding requests for budgets, don't just submit the cost on day one, the 1 year subscription. We'll help you with the tools we got do this whole projection. This is not just a problem you got with Red Hat. It's the same problem that exists with Amazon, Google, and Azure. You know, how long is this cash burn? And most organizations don't predict that or can't predict it. If you're a CFO and you can see month 24 is when it goes into production, you can see the cost impact if something doesn't go into production. You can monitor development progress. If you get to month 18 and see it's not going to go into production by month 24, you can start making adjustments for cash required to continue the project or curb it back. With Oracle Linux, you can curb it back. You can slow it down, but you don't lose the ability to use those tools. With the other tools from Red Hat, Google, Amazon, Azure, you probably would get shut down. So something to consider. So the next thing is, how do you pay for this? You know, so if I take Red Hat, I take Amazon, I take Google, you're going to need to buy something on top of what you've already been spending. So your budget that you got today has to increase from somewhere. So in this case, you know, Red Hat's at $4.3 million, total project cost at $30.129. You're going to actually have to find that money. If this was Amazon, you're going to have to find the money. If this is Google, you're going to have to find the money. But what about Oracle Linux? Do you have to find the money? Well, actually, you already have the money. And in fact, I'm going to show you how you're going to make a profit and actually make some money by using Oracle Linux. So actually, you're going to spend $9.73 million with me over 7 years, but you're going to make money out of it. And I'm going to show you how. Let's go down here. So before you start one of these projects, your existing RHEL subscriptions, 1,000 servers is the example I'm using, with HA and with management tools at 50% discount is 3.234 million. This is just the basic operating system. So hang on a minute. I already have this in my budget today. So I'm already paying for it. So over the next 7 years, I'm already paying for it. In fact, this might grow. As a base operating system, this is something I'm already paying. What's really interesting, I'm going to suggest to you, you should cancel that contract with either Red Hat or Google or whoever it is. If it's the OS in particular, cancel it with Red Hat or SUSE. Why cancel it? Well, here's something interesting. If you cancel this contract with Red Hat, Oracle can take over supporting your Red Hat instances. Okay, that's interesting. That's $3.2 million that you're paying Red Hat that you cancel, but Oracle will take over it. But you still have to pay Oracle. So what you do is take that $3.2 million, move the budget over, and what you need from Oracle, or what you need to pay Oracle, is $1.4 million. That $1.4 million comes from that existing budgeted $3.2 million, and your profit and money come back to the business is $1.8 million. So I actually can make you money by switching over to Oracle Linux, by releasing $1.8 million back to your P&L, and giving you all the tools. So effectively, the $9.73 million that you have to pay me at Oracle becomes free. You're not paying for it. You're already paying for a Linux operating system with Red Hat. We will take over supporting that. And by doing that, you make a profit by getting $1.8 million back to your P&L. So effectively over 7 years, you've not had to find any extra cash. In fact, you've actually got back $1.8 million by 7. Let me do a quick calculation on what that looks like. So if I look at how much you get back over 7 years, it's actually $12.6 million. So you make $12.6 million profit by switching to Oracle Linux for Cloud Native and DevOps, doing the projects I described, funding from an existing project, and it basically costs you nothing. In fact, you made money out of it. Why would you not do it? And to add to that, to remind you, we're standard open source tools. You know, if tomorrow you ran out of money, which I just demonstrated you shouldn't have to run out of money. In fact, you're making money out of this project. But if you did run out of money tomorrow, we can't switch you off. The tools are open source. You can continue the projects in the open community. I'm giving you 56% of your budget back. So, switch over to Oracle Linux software. All the tools are included. You don't pay for any options. When you switch, we give you your money back. We give you half your money back to your P&L, effectively making the project free over the next 7 years. It eliminates cloud subscriptions. One of the things that we're trying to drive is a lot of organizations are getting these tools particularly from Amazon, Google, Azure, and even Red Hat, and you're paying for those subscriptions for the next 2 years before you go live. Instead of staying in the cloud and actually pay for those subscriptions or paying extra to Red Hat, by doing what I've just said to you, moving the budget, you can actually do your dev tests for free. So you can eliminate more money from the cost or from the whole total TCO. The cost savings are phenomenal. I can just keep piling it on and on and on and on. We have some tools. We can help you calculate this, but ultimately what I'm saying is it becomes free. You have to write me a check, but it becomes free. It doesn't cost you anything. And the day you write me a check, over 50% of what you're spending today with Red Hat immediately goes back to your P&L. You make a profit. And we include start and go. You know, when looking at containers and looking at Ansible, we'll put a consultant on site. You know, if you're buying 1,000 servers off us, we're not going to charge you for that. We want to get you going. If you've got 1,000 servers in your data center, you're a busy company. You need some help, and we'll help you do that. So I hope this conversation has been useful. You can send questions to your rep, or you can send them to myself, mickey.barat@oracle.com. Happy to answer them. Call to action is, you know, there are things you can do today without going to microservices, particularly around Oracle workloads. By moving over to Oracle Linux Cloud Native tools, I can give you a check back to your P&L, making your whole project free over the next 7 years. And that's the important takeaway. Pick your vendor based on both two things. What's your commercial and financial impact over 7 years? And number two, if for some horrible reason you had to stop paying those vendors, will they switch you off? Well, Oracle won't, because it's pure open source and you can switch to the community to support you. Thank you for listening. It's been a long 1 hour, and I hope this has been useful. Speak to you soon.